Welcome to the Explainer. Today, we're breaking down a really fascinating proposal that came out of the Smart India Hackathon. It's all about a plan to protect India's absolutely vital coastal ecosystems, and get this, they want to do it using a combination of blockchain, drones, and AI. It sounds like sci-fi, but it's a real plan.
All right, so let's dive right in. First, we're going to unpack the big problem they're trying to solve with India's blue carbon. Then we'll look at their solution, a brand new digital registry. After that, we'll geek out a bit on the high-tech MRV system powering it all. We'll see how they plan to turn all that data into actual dollars. And finally, we'll get to what really matters, the impact this could have in the real world.
Okay, first up, Section 1, India's blue carbon problem. Before we can really appreciate the solution, we've got to understand the challenge they're up against.
So this question really gets to the core of it all. Why can't we trust a tree to be a carbon credit? It sounds simple, right? But the answer is everything. In the whole carbon market, a credit is only as good as the trust you have in it. And the problem is, right now, that trust is, well, it's pretty much broken.
Okay, before we get any deeper, let's make sure we're all on the same page with this term, blue carbon. So what is it? Simply put, it's the carbon that gets captured and stored by the world's oceans and coastal ecosystems. We're talking about mangroves, seagrasses, salt marshes. These are nature's superpowers for sucking CO2 out of the atmosphere. They are a massive natural climate solution. And this brings us to the key challenges. Right now, the whole system is frankly a bit of a mess. You've got data scattered all over the place and none of it is standardized. Restoration projects are often fragmented, done by hand and hard to track. The big one? There's no reliable, trustworthy system for monitoring, reporting, and verification. That's the MRV part. On top of that, the local people who live and work there are often left out of the loop. And all of this adds up to one thing, a massive lack of trust, which makes creating a carbon credit that anyone actually believes in almost impossible.
And, that lack of trust means we are leaving a massive opportunity on the table. I mean, just look at these numbers for India. We're talking nearly 5,000 square kilometers of mangroves alone. Each hectare of these ecosystems can store hundreds, sometimes up to 1,000 tons of CO2. The potential here is absolutely enormous.
So the big question is, how do you fix this mess? Well, this hackathon team, Team CARBONIQ, has an idea. Their proposal is all about rebuilding that missing trust, and it all starts with something they call a new digital registry. Now, what they're proposing isn't just a small tweak, it's a really fundamental shift. See, existing solutions are usually centralized. They rely on these expensive third-party auditors to come in and check things. Team CARBONIQ's idea, it's decentralized, it's community-focused, and it's driven by technology. And crucially, while other systems are pretty general, this one is designed specifically for India's blue carbon ecosystems. Instead of old, hard-to-verify data, they're talking about real-time information from drones and sensors, all logged on a transparent blockchain.
Okay, and the secret sauce here is their three-tier verification process. I think this is really smart. They're building trust from the ground up. So, step 1, it all starts with the local communities and NGOs on the ground uploading field data. Step 2, that data gets checked using technology, AI that analyzes satellite images, drone footage, and IoT sensor data. And then for step 3, the final stamp of approval comes from a national authority, the National Center for Coastal Research. It's like having checks and balances at every single level.
All right, Section 3. That whole verification process we just talked about, it's all powered by some pretty cool tech. So now, let's pop the hood and take a look at their high-tech MRV system.
So MRV, we've said that acronym a few times. It stands for Monitoring, Reporting, and Verification. And you really have to think of it as the engine of trust for this entire system. It's the high-tech, rigorous accounting that proves carbon is really being captured and stored. Without a solid MRV, a carbon credit is basically worthless.
So what does their tech stack actually look like? Well, it's all about layering different types of data. From way up high, you've got remote sensing, using high-res satellite images to map out the big picture. Then you come down a level with drones equipped with LiDAR, which create these incredibly detailed 3D maps of the forests. And then, right on the ground, you have IoT sensors constantly tracking things like soil carbon and water levels in real time. The magic is in combining all of these layers. It gives you a complete, verifiable picture that you just can't get from any one source alone.
And here's an idea that really shows how they make all this big, abstract data tangible and real. They're proposing that each individual tree will have its own QR code for tracking. How cool is that? It means you're no longer just talking about a forest.
You're talking about this specific tree right here. It becomes a unique, trackable, verifiable data point in the system. It just makes the whole thing so much more concrete.
Okay, so we've got a system that can generate really trustworthy data. That's a huge step. But that leads us to Section 4 and the next big question. How do you go from data to dollars? How do you actually turn all this information into a valuable asset that people want to buy?
Well, they've laid out a pretty clear three-step value chain. Step 1. A machine learning model crunches all that field data to get an accurate prediction of the carbon stock, basically how much carbon is stored here. Then, Step 2 is tokenization. That predicted carbon stock gets converted into verifiable, traceable digital tokens on the blockchain. You can think of each token as a digital tamper-proof certificate of ownership for 1 ton of stored carbon. And finally, Step 3, those tokenized credits get sold on a marketplace, which creates the revenue stream.
And you might be wondering, okay, but is there actually a market for this? And the answer is, oh yeah, a big one. Just look at India's biggest industrial groups. Their combined annual emissions footprint is a staggering 53 million tons of CO2 equivalent. They need large-scale trustworthy carbon offsets. This creates a huge, ready-made market for exactly the kind of high-quality credits this system could produce.
Now, of course, a plan this ambitious isn't a slam dunk. There are definitely some real-world challenges to think about. For one, you've got potentially low digital literacy in some of these coastal communities. Then there's the issue of poor or non-existent internet connectivity in remote areas. On the market side, carbon credit prices can fluctuate like crazy, and they need to make sure their whole verification process is not just accurate, but also fast.
But the good news is they've actually thought through these problems and have proposed solutions. To tackle digital literacy, they want to build a super user-friendly app called CARBONIQ, available in local languages with a chatbot for help. For connectivity, they'd collaborate with telecom companies to bring better internet to these areas. And to deal with pricing, they believe their ML models can help predict and maybe even stabilize prices. It shows they're thinking practically, not just technologically.
Okay, this brings us to our final section. And honestly, the most important question of all. Beyond all the cool tech and the financial models, what does this actually do on the ground? What is the real-world impact and who benefits?
And the impact really breaks down into 3 main pillars. You can think of it as a win-win-win. First, there's the environmental impact, protecting biodiversity and coastlines. Second, the social impact, creating livelihoods and green jobs for local communities. And third, the economic impact, generating carbon revenue and bringing in climate finance. It's a system designed to benefit everyone involved.
And on the environmental side, the impact is just huge. We cannot overstate this. These blue carbon ecosystems are absolute powerhouses. Per area, they can suck up carbon dioxide up to 5 times more efficiently than the forests we have on land. 5 times. That is an incredible natural advantage.
But you know, all this data, all these statistics, they only tell half the story. Ultimately, this is about people. To make it real, the proposal introduces us to a hypothetical couple, Aman and Geeta, who represent the people living and working in these mangrove forests. For a family like Aman and Geeta's, this system isn't some abstract concept. It's real, and it's life-changing. It could mean a direct, stable income of somewhere between 8,000 to 12,000 rupees a month. That's money that can help with better housing, with daily needs, and most importantly, with making sure their kids get a good education. This is where the technology hits the ground and makes a real difference.
So this whole proposal really leaves us with a powerful, kind of poetic question to think about, doesn't it? What happens when these ancient, powerful ecosystems meet the trust and transparency of our most modern technology? If we can build that bridge of trust, well, we might just unlock a truly sustainable future for both the planet and its people.